Good morning, everyone. My name is Caroline Sonyong Lee from Hanyang University in Korea. I'd like to talk about my project that I've been conducting for the last 1.5 years. My topic is about gender-based evaluation of soft skin for the application of collaborative robots. The contents of my talk is as follows. I am going to talk about the motivation for my project, which is about the need for the cobots, collaborative robots. And then I'm going to mention the objective and I'll talk about experimental details and results and finish my talk with the conclusions and future work. With the fourth industrial revolution, there are increasing number of robots are being used in the manufacturing sites, especially since the robot requires simple repetition with a delicate hand technology, the needs are being increased tremendously. And since industrial robots continuously and repeatedly move based on coded program, it's inevitable to cause casual accident, especially working with people. Here are the current situation of collaborative robots, where the recently collaborative robot, which is called cobot, is under development, where the cobot can physically interact with people while working in the same place. Here are the annual installation of the industrial robots during year of 2013 to 18th, and from the 2019 to 22. As you can see, there are tremendous increasing number of the robot installation as the year goes up to 2022, ending up the growth rate of a cobot is increasing over 28% up to year to 2025 over the 10 years, according to the globally worldwide, according to Infineon reports. So especially why is the robots are being needed? Robots are specialized for simple and repetitive tasks, while humans are being flexible in solving unexpected emergencies that robots cannot cope with. So therefore, work efficiency, working together with the cobots and the human, work efficiency is greatly improved in industrial sites when using cobot compared to those who do not. So what are the problem? Then what are the problem working with cobot, especially for human? The unexpected contact and the collision with cobot can cause worker injuries along with the discomfort during its contact. Especially, it can cause certain trauma for some workers when they're in contact with the robots. So therefore, our goal is to reduce discomfort by overlaying soft skin on the industrial cobot so that we can minimize the accident minimize accident between the human and the robots. Here are the age distribution of the workers who's working in the electronics industry, where you can see over age of 24 was used as a dividing age, where the number of workers are increasing rapidly. And discomfort due to unexpected contact depends on age, gender, and contact area. Especially, so we have conducted survey over 200 people according to criteria shown below, where the gender, men and women, age, with a dividing line of under age of 24, over the age of 24, and the contact part, especially the body parts where the workers make most of the contact with the cobot when they're in the workplace. So those spots would be shoulder and the elbow. So therefore, the objective of my work was to determine optimal soft robot skin via gender-based evaluation polymeric material. In order to do that, we have selected material suitable for robot skin production. We have conducted preference survey according to age and the gender, and to determine optimum soft cobot skin based on statistical analysis of the survey that we have done. And finally, we have evaluated physical properties to directly relate them with the with the survey analysis results. To select the material, here are the three core conditions that we need to meet. The material need to be harmless, need to be stretchable material for sharp absorption, and material that does not smell strongly, so that people can use alongside together. So Dragon Skin and EcoFlex, which are silicone rubber material for special makeup, are chosen, along with the PDMS, which is a main material for the contact lens or shampoo are being selected for the material. Manufacturing method for this dragon skin, Ecoflex, and PDMS are simple as just mixing those curing agent and those the original material into the weight percent, and then you can only cure under 100 degrees under an hour. So using this simple manufacturing method, it's very easily you can develop a skin material. In order to do the preference survey over those people, we have used three different thicknesses, which is 3.4, 7.0, 10 millimeter thick materials of Ecoflex, PDMS, and dragon skin. And samples are being randomly arranged for fair evaluation. And we have surveyed over 225 people with equally divided into between male and female, under age of 24 and over age of 24. And when we have conducted survey, we have looked at the categories where we have asked those people about how the materials are how the material is sticky when they're having a bombarded onto the material on the shoulder and the elbow, and how you feel familiar with it and how you prefer it. So those are the 4 categories we have studied through the survey. Here are the statistical survey results. As a result, where we have for the male who had a collision on the elbow part, it was found that sample with the low stiffness and high stickiness were preferred, but other groups of males and females over under age of 24 and other parts, that generally samples with the high stiffness and low stickiness were preferred. So in order to relate this static survey to this in relation to the scientific methods, we have used a contact angle test to relate to the stickiness. So contact angle test, as you can see here, measures its angle between the sample surface and a droplet on the sample surface, and higher the interfacial tension as you can see, higher the interfacial tension of the solid surface, smaller the contact angle it gets. And smaller the contact angle, greater the hydrophilicity and adhesion it gets. And therefore, sample with a small contact angle is being considered sticky. And in order to relate stiffness in terms of scientific values, we have conducted compressive creep test. As you can see here, the compressive creep test is an experiment where the specific sample is being pressed under a constant force and then being released to measure how much each sample is being recovered after the deformation in a given time. So therefore, the larger the strain, softer the sample it gets. That means it's decreasing stiffness. Here are the measurement results, where we have a contact angle results as well as compressive creep tests for each of dragon skin, Ecoflex, and PDMS. And as you can see, for contact angle, sample with the largest contact angle was PDMS, while the smallest sample was a dragon skin with the Ecoflex in between. And as a result of the compressive creep test, the sample with the largest strain was Ecoflex, while the sample with the smallest strain was a PDMS. Therefore, the sample with the highest stickiness is a dragon skin, while the one with the least stickiness is PDMS. And in addition, the sample with the highest stiffness is PDMS, while the one with the lowest stiffness is Ecoflex. Here are the results for the statistical analysis that we have done on the preference survey, and we have tried to make an effort to consolidate the factors of age and gender to come up with one optimal soft robot skin material. So first one is regardless of age, we have tried to not consider the age, and then try to select the preferred material for the both male and female. So regardless of age, preferred material was selected, where the PDMS sample was preferred for the man for both shoulders and elbows contact, where the 10 millimeter PDMS and 10 millimeter Ecoflex were preferred for the shoulder and elbows for women respectively. Finally, as I have said before, factors of age and gender were consolidated to find the optimum skin material for the cobots. And based on the preference survey results, skin with the combined PDMS and the Ecoflex seem to be the favorable material for both men and women, regardless of age and contact body parts. So in order to confirm what we have observed through the preference survey, we did the measurement for selectively preferred material. And here are the contact angle test and the compressive creep test for the combination of the 100% Ecoflex to the 100% PDMS. In between is the combined mixed material in weight percent. So to evaluate its stickiness using contact angle, the least sticky sample was found to be 100% PDMS, whereas the most sticky sample was found to be mixed Ecoflex PDMS with its ratio of weight ratio of 7:3. With the increasing, and then for the compressive creep test, which is related to stiffness, with the increasing amount of Ecoflex, the stiffness decreases dramatically. So according to the preference survey results, we have mentioned that workers generally prefer material with low stickiness and high stiffness. So the most probable material would be 10 millimeter thick PDMS sample. However, since 100% PDMS is too stiff to curve around the robot arm to be used for the skin, the mixed sample composed of Ecoflex and PDMS with a 50-50 weight percent would be the most appropriate material when considering its degree of adhesion on the curved surface. So here are the summary and the future work. So for this work, materials for soft robot skin were selected in consideration of the gender, age, and contact body parts. We have chosen 3 types of eco-friendly materials such as dragon skin, Ecoflex, and PDMS. And preference survey indicated that a men prefer PDMS while women prefer PDMS and Ecoflex for the elbows. And to select the optimized material regardless of age, gender, and contact body parts, the mixed sample composed of Ecoflex PDMS with its weight percent ratio of 50-50 has been chosen since it's somewhat flexible while maintaining its stickiness, as its stiffness does not deviate much from our desired standard. For our future work, we are planning on filing a patent on how to attach the selected skin on the cobots, especially on the curved surface. Thank you for your attention.